Welcome to the Talking Risk podcast. We discuss all things risk, hazard mitigation, insurtech, industry insights, and more. I'm your host, Brian Harris, Risk Control Director with FCCI Insurance Group. May is National Electrical Safety Month. Joining us today to discuss all things electrical is John Weber, Principal Electrical Engineer with the Hartford Steam Boiler Company. And John, since we're talking about all things electrical this month, I went to the HSB website, and the first thing that popped up on the screen this morning is what insureds can't see can pose a real risk. That statement sums up my concern with all things electrical, equipment breakdown, fire risk, etc., etc. So, John, welcome aboard. Thanks for joining us on this episode of Talking Risk. How are you this morning?
Great, Brian. I'm fine. Thanks for having me on your podcast here.
Good deal. Well, before we talk about HSB, tell us a little bit about John Weber and your background.
Oh, okay. My background, I have a bachelor degree in electrical engineering and have a lot of experience with facilities management over my career. I worked at some major companies as a director of facilities, worked for a Lego toy company for many years, worked for Allen Bradley Company in Milwaukee. So have good experience. My whole career has pretty much been in electrical and been at HSB now for 12 years. So I've seen a lot of the stuff from the past, and I've certainly staying up with all the things that are part of the present and future.
Well, you're definitely qualified to help our listeners build an understanding of electrical systems and what goes on behind the walls in their buildings. We at FCCI definitely value our partnership with Hartford Steam Boiler. You all do a lot of stuff for us and our policyholders. Briefly tell us a little bit about Hartford Steam Boiler, as we refer to it, HSB, what you guys do. I see that the company has been around since about the just after or just at the end of the Civil War, 1866. So
Right.
tell us a little bit about HSB, what you guys do.
Sure. As you mentioned, HSB goes back to its founding in 1866, and they got their start when, you think about modern technology. Back in 1866, steam power and steam devices, steam generation, boilers was the modern technology of the time. And HSB looked at an opportunity at a time when many steam boilers were somewhat mysterious to the users and they were blowing up at a high rate of failure, exploding boilers. Nobody quite understood this whole phenomenon of steam and how it worked. They could put it to use, but they weren't quite sure all the things that made it safe. And HSB kind of put together a program at the time where they said, hey, well, let's get together some good engineering talent on this question, find out what it takes to prevent boilers from exploding, and let's put together a combined package of inspection and insurance. And in fact, our name is actually Hartford Steam Boiler Inspection and Insurance Company. And it dates back to the concept of inspecting with the intent to prevent the explosion and therefore little need for the insurance in reality. And that's always good for the end user because the explosions and damage to the equipment not only caused loss of life in many cases back then, but also complete business disruption for very long periods of time. But today, HSB has maintained its engineering expertise over all the modern types of technology that are out there. And we consider ourselves somewhat of a technology company in applying Internet of Things devices to help customers avoid problems. And we provide this business interruption insurance and the equipment breakdown insurance to our client companies such as you so that we can work with you and your insureds to prevent and hopefully eliminate the need to ever have to have a claim. And that's always in everyone's best interest.
Well, John, that's well said. And for our listeners out there, you may have already been introduced to a representative of HSB, or you may get to meet one in the future. As John mentioned, they do boiler inspections for us. You may see one of their reps come out there with your risk control consultant if we're doing a thermography scan of your building electrical systems. And we'll get into the thermography a little bit later, but definitely HSB has advanced with the times, going back from the simple, not so simple days of boilers up to, like you said, IoT, sensors, AI, all that kind of stuff. John, there is a statement that I want to look at to key us up here on our next topic. And this is the quote, and this is what concerns me. Just like with that opening statement of things that we can't see pose a risk. So the statement is this, and it's from the National Fire Protection Administration. At least 34% of structure fires in non-residential properties originate with equipment failure, and electrical equipment failure is a very common cause of these fires. And then I've got another statement which may have come directly from HSB, and it says in a recent 4 year period of all equipment based fires, 9,100 of those were caused by electrical distribution and lighting equipment. They resulted in 110 civilian injuries and a cost of more than $297 million in direct property losses. So, from an insurance standpoint, people like myself at FCCI, we get really concerned with property risk, and that's what our consultants do. Go out, look at buildings, try to educate our policyholders on things that they can do to reduce their risk and prevent loss. So, from your perspective at HSB, what kind of things do you all focus on when it comes to electrical systems in a nutshell? What are some things maybe that you all focus on and that our policyholder, business owners, property owners should be focusing on within their properties?
Yeah, right, Brian. Uh, we certainly see a large amount of our claims coming in around electrical based failures, equipment failures. Even though we started off doing boilers, electrical kind of permeates all types of occupancies. Boilers are specific to certain areas, but not all. But electrical, there's hardly a business out there that doesn't use electricity. And one thing we know is that because electricity is a pretty unlimited energy source coming in from the utility grid into the building, if things aren't installed properly, maintained properly, and worked on safely, real bad things can happen. And that includes loss of life, loss of property, and loss of complete businesses too. One thing we know is that the electrical equipment does require maintenance. It's not maintenance free. Most people might look at electrical equipment and say, even in your own house, you might say, oh, I've got that panel down in the basement, but that doesn't need anything. It just sits there and does its thing all day long. There's no moving parts. I don't hear any sounds coming out of it. That must be okay. And as things age, this is a major problem too. As electricity's been around for quite a while, some of these systems may go back to the point of origin of the technology. They may not be as safe as things are today. But one thing HSB has kind of found over kind of looking at the types of claims that have come in over the years is that a lot of electrical losses and failures and the resulting business interruption losses that go along with the equipment breakdown can be eliminated by a simple concept of keeping the electrical equipment clean, cool, dry, and tight. That simple statement can account for about 68% of the electrical failures that we see coming in as claims. And I know that's a simple statement, but it is something that almost everybody can understand at any level of electrical proficiency. If you walk into an electrical room or even in your basement, even a homeowner could use this concept of clean, cool, dry, and tight. Everyone knows what those three words mean. But if you look at the panel in your basement and there's water coming in through the window or through a crack in the foundation and it's dripping into and onto the electrical panel, that's an easy thing to take some kind of intervention and say that doesn't seem right. That's one of those four criteria that keeps me 68% problem free. So also clean. You look down there. There's spider webs, dirt, rocks and stones around the electrical equipment, or hit by a lawnmower out in your front yard. Similarly, in a business, when you see this kind of damage, many people get used to it and say, that's normal. It's been like that for 3 years. Why should I take some action? Well, because at some point in time, that electrical equipment is going to have water get into it if the cabinet doesn't seal right. Well, all these things are going to progress to the point of failure. And then it's not just that you're going to have an equipment breakdown and have to file a claim. The bigger thing is that you're going to have a major disruption to your business. And some of that stuff is not recoverable. If your customers decide to go to your competition while you're down getting your electrical service back up, that can be a real problem. And I've even seen that firsthand on some claims I've gone out to look at. I remember going out to a guy who operated just a car wash business, and he had major electrical problems. He was down for a significant time. And he told me that he had to watch all of his customers go down the street to his competition just to wash the cars now.
So something as simple as the concept of keep things clean, cool, dry, and tight can keep you in business, basically.
Yeah, and when we did the simple math on it based on some data we analyzed, it looked like those three things can account for 68% of the problems that do occur. That's pretty good without getting too technical.
What would you say then are some key basic pieces of an electrical preventive maintenance program that a business could implement from even a business as simple as maybe an office up to an industrial type operation. These concepts are applicable to both, but what are some things maybe for somebody out there that doesn't have an EPM program in place? What are some of the basic things that you might recommend that they do to get started?
If they're not operating a current electrical preventive maintenance program, then the recommendation really would be start thinking about getting one. Even if it's a simple thing, if you don't have a lot of electrical equipment, even think of your own home and you say, how much simpler can it be than my electrical in a house? That's probably the least complicated occupancy. But you still need to say, I got to go down and really want to check what the original equipment manufacturer recommended be done for the equipment that you own. Now, that would apply to a home or to a business or large business or institution, whatever. The real key to a good electrical maintenance program is knowing the electrical equipment that you have, and then what is the original equipment manufacturer's recommendations for the maintenance of those devices. And this could be anything from operated switches, manual switches. It could be motors that you have in place. It could be even, your customized equipment for your business. There'll be recommendations for lubrication, cleaning. All these things are defined. There's hardly a producer of anything, electrical or even mechanical equipment that's used in the occupancies we insure, that doesn't have recommendations for maintaining it. And that's really the best source of the information for what you should be doing. And think about everything you buy when you buy it. Think even just in most simplest terms, think about things you buy for your home. They all come with some type of instruction booklet. Maybe it's your vacuum cleaner system you bought, and you say, oh, look there's even a maintenance section here, what I should be doing, when I should be replacing, what I should be lubricating. That's in the most simplest form. In an industrial setting, there might be a complete book written by the OEM for what should be done to the equipment on site. And I even ramped that up to an easy to understand analogy. Think about your own automobile you drive. Assuming you own your car versus lease it, there's a full maintenance schedule mandated or recommended by the vehicle manufacturer, when to change the oil, when to change the filters, how to determine when these things are dirty. And you can do all these things. A lot of them aren't complicated things, but you just have to be aware of what the maintenance schedule is for this equipment, and then start to carry that out. When we talk about electrical equipment maintenance, there certainly are, if you bump up the concept of clean, cool, dry, and tight, you're kind of pushing yourself into a new standard that was just released by NFPA. And that would have been, the beginning of 2023. They came out with the standard for electrical equipment maintenance. And that book is kind of like a nice cookbook for a large organization to look at, because it defines the way to achieve good maintenance on your electrical equipment after it's been installed correctly to begin with. The National Electric Code, NFPA 70, covers the initial installation of the equipment. But what everybody realized was that, but what happens 5, 10, 20 years later if nothing else is recommended to be done with this equipment? We only look at it when the building inspector or the electrical inspector comes in and approves your permit. But then 5, 10 years go by and nobody's looked at this equipment. They've realized that something was missing. So NFPA rewrote NFPA 70B from a recommended practice for electrical maintenance, equipment maintenance, to a standard for electrical equipment maintenance. And then by being a standard, they use different words in the document form, such as defined words, such as the word shall, which within the document means that you must. All right. In the recommended practice document, it said things more like, it's a good idea to do this, but there was nothing that would kind of mandate it be done. The way the standard is written now in the standard document form, it's actually an enforceable document should any authority having jurisdiction have the ability to enforce it through legislation. Like the National Electric Codes, NFPA 70 is actually state law to follow that in most states, but NFPA 70B is not. But at some point in time, different jurisdictions could say, hey, we want to make 70B a law, just like we make it a state law, just like we did with 70. And then that could be not only a good thing to do or engineering best practice to do, but it may actually, or it could become the law to do it if any legislation mandates it.
John, you read my mind, because as you were speaking, I was thinking about NFPA 70 and 70B and those changes. Electrical systems are things that need to be maintained. They're almost like a living, breathing organism. Once they're installed, doesn't mean you can just forget about them. They need a little TLC and attention from time to time to make sure that they're not going to be cause of some type of failure, fire, or other loss. So I think it's important for building owners to realize that once those systems are installed, there's still going to be some manufacturer recommended guidelines to maintain that equipment. And now with NFPA 70B becoming a standard, it could potentially be something that's enforceable. At FCCI, risk is our business. We provide services that help business owners better understand and minimize the losses they face every day. Our experienced and credentialed professionals have worked in a wide variety of industries, including agriculture, construction, manufacturing, retail, service, and wholesale distributing. FCCI's risk control consultants meet directly with policyholders to learn the unique nature of their business, combine individual recommendations with online resources and tools to create a custom-tailored plan. Our risk control programs provide clear goals, action plans, and survey schedules to help policyholders accomplish their safety objectives. To learn more about FCCI's risk control resources, contact your agent or visit our website www.fcci-group.com and click on risk control. John, in your experience at HSB, and this is sort of I don't want to put you on the spot, how are property owners out there doing with the concept of electrical preventive maintenance? Is it something where, in your experience, building owners are doing things that they should be, or is this an area where we need to improve?
Yeah, I think in general, it needs to be improved upon. There certainly are those companies that are making lots of money and say, hey, we've got enough money to have a full-blown maintenance staff, and we hire licensed electricians, and we have licensed plumbers, and everybody here is the top guy we could hire off the street to do this trade job. And we have them all in-house. They're all we value our business so much. We don't want anything going wrong with this. We don't need anyone to tell us that that's a good thing. We understand that directly ourselves. And we make it our own business model that anything we invest in and we put in as equipment will be maintained to the utmost degree following the OEM's instructions. And then there are other companies everywhere on a slide wire in between that level down to people who are like, we're just barely getting by. We don't make much money every year. If we had $100 left over, I don't know if I'd want to spend it on going around paying an electrician. I'd rather spend it on something where there's a greater need. So you can imagine the types of businesses, and those that are highly profitable versus those that maybe are just squeaking by. And anytime money's involved, it's going to directly impact the degree of what you can afford to do. And sometimes you can just do a different level and still do the right thing. There are different levels of preventive maintenance where, even if you look at NFPA 70B as it was rewritten as a standard now, it kind of talks about the maintenance for your equipment to be based on a condition assessment. So, when you say, well, what frequency should I be doing all these things within NFPA 70B? Also realize that NFPA 70B number 1 says you must follow the OEM manufacturer's instructions first. 70B is like a secondary kick-in. It isn't the primary. So 70B says if you have the manual from the company who made your equipment, that takes precedent over anything we recommend in 70B. You can combine them if you want, but if the manufacturer says otherwise, you should follow that. That's the person who knows the most about what to do with that equipment. So, and let me just wrap up too on the NFPA thing. NFPA kind of regards 3 documents that they put out: NFPA 70, the electric code; NFPA 70B, the standard for electrical equipment maintenance; and NFPA 70E, which is the standard for electrical worker safety. And what they do is a lot of times you can actually buy those 3 documents from NFPA as a bundle because they kind of make up what they consider the 3-legged stool for complete electrical consciousness of what's going out there. Number 1, 70E is like when you're putting things in, you have to do it safely so nobody gets hurt. And NFPA 70 says you have to put it in properly when you put it in the first time. And then 70B follows up and says, and you got to keep it up over time. And the condition assessment within 70B can give you different frequencies based on how your equipment is evaluated to be at the time of the condition assessment. and they'll define things as like, is the equipment like brand new, like it just went in and the paint's all fresh, there's no scratches, there's no broken hinges. Then you can follow condition assessment level one, and that might require annual maintenance on something. But if you go all the way, those three levels of a condition assessment, you could have two or three, with three being the worst. And if you have condition three, it might say you haven't done any maintenance in the past. This is your first time coming upon this equipment, and you've had major problems in the past that haven't been fixed. Well, then the frequency would change. On that type of equipment, they might recommend 6 month frequencies for that equipment initially, until it reaches a new condition assessment from being maintained properly. But if you have a company that hasn't done anything ever, but they finally are enlightened and say, hey, I want to do something right now where we are making money, I have money to put toward this. And they say, my condition assessment of my equipment is condition three right now. It requires much more frequency of maintenance. But once I get it up to the point where it's in good shape again, it's going to go back to be condition assessment one, and you may have to only do maintenance on it every year instead of every 6 months, according to NFPA 70B.
Good deal, John. Thank you for that information. And for our policyholders out there, there is some information on the Risk Solutions Network portal. We actually have a link in there to an HSB site where you can take an electrical self-assessment. So if you've never done anything before with regard to your electrical systems, that might be a good place to start because it could give you some pointers on some things you may need to focus on. So if you have accessed the Risk Solutions Network before, you can find the link to the HSB material right there in your content library, or down at the bottom on the left-hand side, there's a link for HSB equipment efficiency. You click on that, it takes you to an HSB website, and then you'll see several different resources that you have access to, in addition to things like an equipment efficiency calculators, pre-emergency planning, weather and disaster preparedness, uh, materials on equipment care, as well as different types of logs and checklists to help you stay on top of your systems and your equipment in buildings. But that self-assessment is a nice, simple 10 or 12 question survey that you can take, and it'll give you some basic recommendations after that. And then finally, if you are a policyholder listening to this episode and you haven't previously accessed the Risk Solutions Network, reach out to your risk control consultant and we can get you a login so you have access to that as well as all the other materials that are on there. And John, I'm going to skip around to our last topic and then we'll go back to surge. But since we were talking about things that a building owner can do to stay on top of their systems, maybe now's a good opportunity to talk about thermography briefly. And I would say that several of our risk control consultants at FCCI have basic FLIR infrared cameras that basically plug into your phone, and you can use those as a very basic way to scan the systems and get an idea of the temperatures and what's going on behind panels or in motors. And you guys at HSB obviously offer higher level thermography scanning services and do that for several of our larger building policyholders. But the little FLIR cameras like that we have here at FCCI, you can buy those online for a few $100s. So it may be something worth considering if if you don't have much of a program in place yet. It might be worth investing a few $100, getting yourself one of those cameras so you can at least get an idea of what's going on in some of that equipment, to give you a heads up that you need to call out a licensed and insured electrician to do a deeper scan or maybe to make some type of repair. So, John, talk a little bit about thermography. What is it? What does it do? And then maybe a couple takeaways that we could use to identify potential problems.
All right, great, Brian. Yeah, the thermography, as you say, HSB has professional certified thermographers who do this as a living all day long, and they'll go out to a facility with much more expensive cameras than the small FLIR on a cell phone. And a big thing about thermography is not just having the physical equipment to take the picture; it's a thermal image of what you're looking at. Just to understand, thermography is an infrared camera that sees heat, and it sees different levels of heat in different shades and colors depending on how the camera is designed. And let's say you look at something through the infrared camera. Say you're looking at an electrical panel, and you might see, oh, there's an area here that's really yellow, but then down here it's showing it's red or it's blue or some other color, that a shade, and then there'll be a temperature scale associated with the color variances on the camera or in the settings, where the user can say, whoa, if I see yellow through this camera, that's 192 degrees Fahrenheit. If I see red, in this shot, that might be only 100 degrees Fahrenheit or less. So you can see what the temperatures are in relative terms, like this is hotter than that. But you can also see the actual temperatures that it is in terms of a measurement. So it's qualitative and it's quantitative in terms of looking through the camera. Now, the biggest thing with thermography is knowing how to interpret what you're looking at. And that really depends on your understanding of what the equipment is in the first place. If you're looking at a three-phase disconnect for a motor, and you're looking at it and you see a yellow area on one of the wires and you see two red colors on the other two wires of the three wires, then you have to say, well, does that mean something to me? How do I interpret this? What does it mean? I can tell you definitely that the A phase wire might be 50 degrees hotter than the other two, but what does that mean to me? And is that normal or is that abnormal? So you'd have to have like this basic understanding that if you're looking at a piece of equipment such as a three-phase motor, the first assumption is all three wires on that motor should be drawing exactly the same current. All right. And you have to have this knowledge to interpret the heat signature. And then if that's true for an electric motor, then you would have to deduce from that, well, why is one hotter than the other if they're all drawing the same current? They must not be drawing the same current, but they're supposed to be. So from that, you determine that this is either normal or abnormal. Another major thing you have to remember when you actually try to perform a thermal scan with the camera is that it's only meaningful if the loaded wires or equipment you're looking at have an actual current draw on them, meaning that they have to be operating at the time you're viewing them. If I took the cover off my electric panel in my house and I looked at all the circuit breakers when nobody was home, I would see all the wires are as cold as can be because I wouldn't be drawing any electricity in the house. And I would expect all those wires to look ice cold or ambient temperature because there's no current, nothing's running, none of the lights are on. And so in order to use a thermal camera, you have to load the circuit up to 60% of its normal load, because the current running through the wire is what actually generates the heat through a poor connection or a high resistance joint. That's the whole principle behind why you're doing it. But it's meaningless if you're not doing it under a controlled awareness that this equipment is on right now and it's fully loaded, and therefore if it's drawing its proper amount of current, it should be doing so without overheating the equipment. But if it's not turned on, it's a meaningless test. But one of the things, just to pull these things together, NFPA 70B, when it was rewritten as a standard, now calls for thermography for all electrical equipment. And keep in mind that this is a backup to the OEM's recommendation. If the OEM says you should be doing thermography every month on this equipment, that takes precedent over what 70B might say. And what 70B says, if you have condition assessment level 1 for your equipment, which means it's like brand new, then you should be doing 6-month intervals for thermography. I'm sorry, 1-year intervals for the thermography in the facility. And if you have condition assessment 3, which is the worst, where nobody's been doing anything to it for a long time, then you should be doing that thermography at 6-month intervals. You see? So the condition assessment changes the frequency. But one thing that's sure is that all electrical equipment now is calling for thermography either at 6-month or 12-month intervals. If you are following NFPA 70B, that's a requirement. It's not optional because the standard was written to mean you shall. And anything that was kind of less important, they actually pulled out of the old recommended practice document because they said, well, if we don't want to enforce it, then why recommend it? When they rewrote it from a recommended practice, there were a lot of things in that document where they said, oh, you could do this and you should do that. And it's a nice idea to do that. But then they said, yeah, but we don't want to enforce that. It could be excessive. So even going to a standard, some things were actually eliminated. But the things that are in there are now pretty much required. But they're not required by law, but they're required by anyone who professes to maintain to 70B. At some point in the future, 70B could become a law, but you have to watch how that develops in your own jurisdictions.
Hey, John, what would you say is the most common deficiency that HSB discovers when doing thermography scanning?
Yeah.
Is there a most commonly cited recommendation or issue that is resulting in those differences in temperatures that point to a potential problem?
Yeah, yeah, there is. We'll see repeated, I mean, even multiple incidents with any review where there's multiple, let's say, three-phase disconnects or switches that have high temperature at components within the switch. It could be at the fuse holders where the fuse snaps into the clip, or it could be where the blade attaches to, from the stationary, like at the hinge points of the blades. And very commonly, it's also at just where the wires are terminated onto lugs within equipment, like the line side connection to the switch, 3 wires on a 3-phase motor, for instance. And then there's 3 connections on the load side. Sometimes those connections were never put on tightly, or they loosened up over time, or this whole concept of clean, cool, dry, and tight was not carried out, and it got wet inside, and then corrosion built up a really bad connection. Even though it's tight, it's a corroded connection, between maybe an aluminum lug and a copper wire, or an aluminum wire and a copper lug. All kinds of things that are related to field connected points in the system are very common.
So it sounds like at the end of the day, all of us should have some type of electrical preventive maintenance controls or procedures in place. Keep it cool, clean, dry, tight. I mean, that sounds like that's the answer to a lot of our problems out here. Give your systems a little TLC, pay attention to them, and if you take care of it, it'll take care of you. This is Talking Risk, the risk control podcast from FCCI Insurance Group. You can find us on Apple Podcasts, Spotify, or by visiting our website, fcci-group.com. Click on Risk Control, then Risk Control Resources, and select the episode you want to hear. So, John, last topic for this episode, I wanted to touch on surge protection with you. And, I'll confess as well, I've gone through some of your trainings in the past, but it's still somewhat of a concept that I struggle to get my mind around when it
Yeah.
comes to this idea of surge and surge protection. Most people possibly listening to this episode, when we think of surge protection, we think of that little strip under our desk or on our workbench that has multiple receptacles and you can plug devices into it. And when you do that, you think you have surge protection. That may or may not be true. Tell us a little bit about surge and then where it comes from and some of the different ways that it can be protected against.
Okay, great. Yeah, Brian. There have been some studies in the past, not HSB studies, but other organizations who've studied the problem of power quality and surge. And they've kind of broken it down that 80% of surges actually come from within or local to the property in question. So you could have something in your own house, take it down to the simplest level again. Say you have a vacuum cleaner or something with a motor on it, and every time you turn that on, it generates some undesirable condition on the power line that everything else in your house sees and picks up and doesn't like it. And it doesn't actually cause it to not work, but it could start some kind of deterioration process to this other connected equipment. Now, they also found that like 20% is coming from outside of your building through the power line. And those could be things like the utility company is switching their lines and opening a switch and closing a switch or switching capacitors on the system. You have no control over that. And some of it could be coming in through storm-related events, some kind of a lightning induced. And I'm not talking of a direct hit lightning strike, which would like knock your chimney off your house or something, but something that has an induced effect into your power coming into your home or business. Those are only like 20% of the problem. And when you get into surge protection, it's the recommendation is to have three levels of surge protection and not just that strip that Brian was talking about, but that's what most people perceive to be, yes, I do have surge protection in my building. I have one of those at all my cash registers or, any place where I use electronic device, my PA system or something has got one of those. But that's the weakest and least capable level of surge protection in a properly deployed system. Well, there's actually a level one, call it a type 1 SPD or surge protection device that you would want to install at your main switch location on the property. And then there are level 2 surge protection devices, they're abbreviated SPDs, that are used at all of the remote sub panels within your building. Now, some businesses don't have many sub panels, so your type 1 and type 2 might all be the same location because everything comes in at one switch and there aren't any other. It's a smaller building, 2,000 square foot building may not need a lot of sub panels. Even think of your house. You have one panel down in the basement. You don't usually have many other sub panels. Occasionally you do, but it's all in one place. But the National Electric Code currently requires any new panels in homes to actually have surge protection devices installed by the electrician when he installs the service on the house. Now, this developed because the authorities found out that the average simple home today has about $14,000 worth of destroyable electronic equipment in it. And think about that. If you think back years ago, a lot of people might have said, why would I want to put surge protection in my house? It's a waste of money and time. I don't have anything that's needing surge protection. I've got old-fashioned everything, don't have any electronics, nothing in the house. But what happened over time is pretty much everything turned into electronics. Now, I'll give you some examples. When was the last time you changed a 60-watt bulb in your house or your business? All right. That is not a tungsten element light bulb anymore. Everybody uses this word kind of casually. Oh, it's an LED bulb. Well, what does LED stand for? It's a light emitting diode. And what is a diode? A diode is an electronic device. So, the old light bulb, the old 60-watt light bulb, 100-watt light bulb used in a business or a home was pretty safe against surge damage, because surge damage is like a high voltage spike for a very short time that occurs on the line, and it's either happening from something coming into your property from outside or from something in the house that's causing it to occur on other connected equipment in your house. But that surge protection is what you're trying to prevent, and you're really not going to get a full protection unless you do the three types at the main service, the sub panels, and then at the what they call the point of use. And I always kind of make this analogy about surge protection almost being like the Secret Service protection of the White House. All right. If you're trying to get to the White House, what's the first thing you have to do? You have to get through the fence. There's a fence around the building. All right. So that's your type one surge protection. It's preventing stuff from the outside getting on the White House property. We're not even talking about the White House itself. You can't even get on the lawn yet. All right. So you have to break through the fence. That's your type one. Then once you get on the grass and you're running around and you're trying to get to the building itself, that's your type two. You got other things out there. You got people with dogs and rifles and people who'll tackle somebody coming in there with for uninvited. That's your type two surge protection. And then the type three is the two or three guys that walk alongside the president all the time. They're the last saving grace for the protected person. That's your point of use and the place where it's your last chance to save the person. And that's how surge protection works. And one thing about surge protection devices, they are considered sacrificial devices. They don't last forever. If you have a lot of surging going on for whatever reason from whatever sources, that every time that surge protector does its job and it takes away the energy of the surge and protects your equipment, it erodes a portion of itself. And people might say, well, how long are these things going to last? How do I know when I need a new one? Well, it could be one surge could kill it in one day, but it could take 1,000 little surges to kill it and make it non-functional. Most good surge protectors have a working, not working LED on it. So if you do have surge protection devices, it's not enough to just put it in and again forget it. Somebody has to go down there periodically and look at those lights. And if the instructions on the SPD says all three green lights must be on for this to be working, you have to check that. If one light is on red, that SPD needs to be replaced. It's no longer functioning. Well, one of your phases is no longer protected. But again, going back to the house analogy, remember we said the 60-watt light bulb today is actually an electronic device and is vulnerable to surge damage, as opposed to the old tungsten element bulb. But other things in your home today, you all know that you have, and this is your business too, but you all have these ground fault circuit interrupter receptacles all over the place, in the bathroom, outside, in the kitchen. Those are electronic devices. They look like power devices from the outside. You just plug a plug into them. They look like the old-fashioned plug. But if you ever opened one of those up and looked inside, it looks like it's an AM/FM radio inside there with all kinds of stuff on a circuit board. And what good is all that protective equipment that prevents you from being electrocuted if you take one surge and it wipes all your GFCIs out, and they're all hardwired into your business, but they're all not working because you didn't have surge protection? So this is kind of where this $14,000 per home. But then you say, what about my stove, my microwave, my washing machine? All of these have electronic circuit boards now. Even the Mr. Coffee Pot has an electronic board in it. This wasn't the case years ago. So it's become mandated by code now for homes, and certain business requirements are included. At some point, they may require it everywhere, but currently it is required for homes. Even if you have an existing service and you have it replaced in a home, that new service has to have a surge protection device installed.
John, I think that you do a masterful job at taking a complex concept and boiling it down to something simple that I can remember. So I will forever think about surge protection in terms of the Secret Service. And like you, that's
Well,
true
that's
because
wonderful.
it's an easy concept, right? You've got
It
these
is.
three layers, and like you mentioned with the actual devices that they're sacrificial. It's the same thing with the Secret Service, right? If somebody
Exactly.
if somebody smashes through a gate, the gate is damaged, it has to be replaced.
That's
If
right.
somebody gets onto the lawn and they get tackled by a Secret Service agent, or there's a scuffle with a dog or something, the agent or the dog may become injured and they've got to be repaired, you
That's
know?
right.
And
That's right.
if they get to the final layer of defense, all know, watching Hollywood movies and stuff that, you
Yeah,
know, are you willing to take a bullet for the president? They're
that's
supposed to
right.
do that, and it's a sacrificial concept. So,
That's right.
everybody listening out there, surge protection is important. If you haven't given much thought to it, you should. I encourage everybody listening, go to the Risk Solutions Network, take the electrical self-assessment. There's, no charge. It's accessible to all policyholders. And if you have any other questions or concerns about your property, electrical risk, reach out to your FCCI risk control consultant and we'll help you in any way that we can. And we always have experts that are knowledgeable that we can go to when needed, such as John Weber. So, John, I really appreciate you joining us today to talk about all of these different electrical systems and concepts. So, thank you very much to you and HSB and all that you do for us. We appreciate it. Thanks for coming on today.
All right, great. Thank you, and have a great day, Brian.
This is Talking Risk, the risk control podcast from FCCI Insurance Group. You can find us on Apple Podcasts, Spotify, or by visiting our website, fcci-group.com. Click on Risk Control, then Risk Control Resources, and select the episode you want to hear. For Talking Risk, I'm Brian Harris, Risk Control Director with FCCI Insurance Group. Recording copyright FCCI Services Inc. 2022. The opinions expressed in this recording don't necessarily represent those of FCCI, its personnel, or affiliates. This recording is provided for informational purposes only, does not attempt to identify all potential hazards or remedial actions, and is not intended as legal or professional advice. FCCI, its personnel, and affiliates shall not be liable for any loss, death, damage, or expense arising out of your reliance upon this recording. You are solely responsible for complying with applicable law, including any changes in the law, and for the safety of your operations. Please consult your legal advisor with any questions or concerns.